Hi guys, welcome back to 19.6 part 3. I'm going to try to finish the rest of the examples in this note. So we're going to start looking at this particular question. Find the solution of 3 sine square x minus sine x minus 2 equals to 0. Now keep in mind, we're not looking for all solutions. We're only looking for solutions that falls within the interval negative pi to pi. Okay, so if I take a look at this particular question, I do notice a lot of times, guys, you have to focus on the structure. So I have 3 sine squared x minus sine x minus 2. It's a trinomial. The first term is squared, the middle term has a power of 1, and the last term is constant. What does that remind us of? Quadratic. So for those of you who are having trouble seeing this, you can go ahead and utilize what we know, which is the u sub method. So we're going to say let u equals to sine x. Okay, if I let u equals to sine x for this particular question, then I can rewrite this as 3u squared minus u minus 2 equals to 0, which then becomes quadratic, something that we know what to do with, which is factoring. So this factors into 3u plus 2, and then u minus 1 equals to 0, which means u equal to negative 2 over 3, and u equals to 1. Now, keep in mind, what does u stand for in this particular question? U, remember how we set it up, u originally stood for sine of x. So what we need to do now is go back and replace all the u's with sine of x. Okay, so sine of x is then equal to negative 2 over 3. Okay, and sine of x is equal to 1. Okay. I'm going to erase all thing here. Now, do I know any special right triangle or special angles that will give me a sine value of negative 2/3? No, but I do know sine of what angle is 1, and that's pi over 2. Okay, and the next one we'll remember, sine of x equals to 1 only once in the whole entire period of 2 pi. So it's going to be at pi over 2, and then 5 pi over 2, and then 7 pi over 2. So, not pi over 2, 5 pi over 2, sorry, 9 pi over 2. So there is only going to be one value of x within the negative pi over and pi, where sine of that particular value equals to 1. So for this one, we know x is equal to pi over 2. Now, for this top one, sine of x equals to negative 2/3. If I cannot figure out what the angle is without a calculator, that probably tells me I need a calculator. So then we're going to rewrite this as x equals to inverse sine of negative 2/3. Okay, which then I need a calculator. And again, please check to make sure your calculator is in a radian mode before you start using it. Okay, so we're in radian mode, and I'm talking about the inverse sine of negative 2 divided by 3, which equals to, according to my calculator, again, approximately negative 0.730. Now I need to double check something. On a unit circle, my little sketch of unit circle, okay, where would negative 0.730 fall into? Well, it will actually be in the 4th quadrant, okay, so there will be the angle, and that angle is going to be negative 0.730. Now, where else is sine negative? Well, that will be in the 3rd quadrant, okay? And the reference angle has to be the same, so it's negative 0.730. Now, positive 0.730 for my reference angle right here. Now, normally you would say, well, that doesn't matter because it's in the 3rd quadrant, but here's the thing. When you go from negative pi to pi, you are talking about still the whole entire unit circle. You're actually talking about this is negative pi. When I rotate all the way to here, this is negative pi, okay? Which means this particular angle in the third quadrant actually still is a solution that I need. But the question is, how do I figure out what that is? Well, if you take a look at this whole entire thing is negative pi. And this is my reference angle. So to find the actual negative angle, which is this one, all I have to do is just take negative pi plus the reference angle. Okay. Which is going to give me negative 2.412. Okay. So that means for this particular question, I actually have 3 angles who falls within the boundary of negative pi to pi. The first one is pi over 2, okay, which is within the positive side. The 2 other answer, one of them is negative 0.730, and the other one is negative 2.412, because you have to keep in mind, negative pi, the approximate value of negative pi is negative 3.14, which negative 2.412 still falls in with that boundary. So for this particular question, I'm going to get 3 answers. And again, you can verify all your solutions by using decimal or graphing calculator. Okay, let's move on to the next one. So solve tangent of x cosine squared of x equals to tangent of x. Ooh, this is a tough one because I actually have 2 different trig ratio here. I have both tangent and cosine. So what am I going to do? Well, first of all, guys, please do not divide both sides by tangent of x. We had this conversation already. You cannot divide both sides by a variable because what if that variable equals to 0? Same thing here. I cannot divide both sides by tangent of x because what if that tangent of x equals to 0? So what we're going to do is we're going to actually combine the 2 terms together into one side. Once I do that, the question is, I'm still going to try to factor. What do they have in common? Oh, wait a minute. They have a tangent of x in common. So if I factor out a tangent of x, I'm going to get cosine squared x minus 1 equals to 0. Oh, I can set both factors equals to 0. So I have tangent of x equals to 0. And then cosine squared of x minus 1 equals to 0, which then means cosine squared x is equal to 1, which tells me cosine of x is actually equal to 1 or negative 1. So we're going to come back to the cosine question. Let's talk about the tangent of x question. Where does tangent of x equals to 0? Well, I know at x equals to 0. But again, this particular question didn't give you a boundary on where your x is supposed to be, so you need to provide all the solutions. So let's come back again. Where does tangent equals to 0? Well, tangent of x equals to 0 when x is 0. The next one is pi, and then 2 pi and 3 pi. Do we see a pattern now? We're talking about multiples of pi. So let me go back and erase this. And we're going to write, it is n pi. N is an element of integers. Okay, so that gives me all the solutions for x value where the tangent of that angle will give me 0. Now let's come back to the cosine portion. Okay, so I gotta erase a little board because I need more space. They're right on top, so I'm going to say cosine of x that's not good. So cosine of x equals to 1. And then cosine of x equals to negative 1. Oops, need a little space. You know what? I'm going to shift this whole thing over so you guys can see what I'm writing. Okay. Cosine of x equals to 1. And cosine of x equals to negative 1. Let's think about this. Where does cosine of x equals to 1? Oh, that's right. Cosine of x equals to 1 at 0. Cosine of 0 equals to 1. Because if you remember the cosine graph, it starts with 0 and then starts with 1, 0, -1, 0, 1. So cosine of 0 is 1, and the next one will be 2 pi is 1, cosine of 4 pi. So we start seeing the pattern. So we're talking about multiples of 2 pi. So x equals to 2n pi, and n is an element of integers. Now, where does cosine equal to -1? We just talked about it. So cosine's table of value goes from 1, 0, -1. So cosine of pi is -1. But the next one we're going to have, remember, the period for cosine is 2 pi. So the next one we're going to have is at 3 pi, and then 5 pi, and then 7 pi. So what are we going to do here? Well, we're going to say, we're going to start at pi, because that's the first value we can think of where cosine of that value is equal to -1. And from there, I'm going to add multiples of 2 pi to get to the next value. And again, n is element of integers. So 3 answers. X equals to n pi, x equals to 2n pi, and then x equals to pi plus 2n pi, and n is element of z. Now before I move on, I hope you guys caught this. These are, first of all, right here, you're talking about multiples of 2n pi, which means you're talking about all the even pi's. Over here, we're talking about all the odd pi's. But then over here, my answer here includes any multiples of pi. So doesn't the solution here for x equals to n pi, doesn't that already include all the solutions we have up here and here? That's right. So for me, the only solution I will have to write is this one, because this particular solution here will already include everything I want, whether it is a even multiples of pi or odd multiples of pi. So for my solution, all I have to indicate is x equals to multiples of pi, and that n is an element of integer. Okay, moving on. So, taking a look at this question. Now this one also proposed a problem because I have both cosine and sine. Now we know how to do a trig equation that's in a quadratic form if they are both the same trig ratio, sine or cosine. But do we know how to do it when it's two different trig ratios? Well, the question now becomes, is there any way I can take the sine of x and switch into cosine of x? No, we don't have anything that helps us to do that. But is there anything I can use to take cosine squared of x and somehow swap that to sine of x? I'm hoping you guys are thinking what I'm thinking, which is the Pythagorean identity. And which one am I thinking about? Well, sine squared theta plus cosine squared theta is equal to 1. So remember, we talked about this. You have to write on the side or communicate your Pythagorean identity when you actually use them. Excuse my handwriting, guys, because I'm using my finger to write. So in this case, cosine squared theta is going to equal to 1 minus sine squared theta, which means I can rewrite this as -10, 1 minus sine squared theta minus 3 sine x plus 9 equal to 0. Okay, so I can go ahead and distribute. I'm going to get -10 plus 10, again, distribute evenly, please, minus 3 sine x plus 9 equals to 0. Start combining my terms. So 10 sine squared theta minus 3 sine x minus 1 equals to 0. Okay. Can we factor this? Oh, sorry, should not be theta. It should be x. Let me fix that. Okay. We should be able to factor this into 5 sine x, and then 2 sine x. Minus 1 plus 1 equals to 0. Okay.